MATLAB has a symbolic math toolbox that allows you to do math on symbols. That might sound easy, but it actually is more difficult to write code that would add x plus x and give you 2x, rather than just saying 1 plus 1 is 2. We can create symbolic variables and symbolic expressions using the sim function, sym. For example, if I said a gets the value sim of quote, a is now a symbolic variable. A shortcut for this, if you wanted to have 3 symbolic variables, for example, x, y, and z, instead of saying x gets the value sim of x, y gets the value sim of y, z gets the value sim of z, you can just say sims x, y, z, and it will create all of those as symbolic variables. You can also create a symbolic variable that stores a symbolic expression, for example, sim of the string x cubed minus 2. So notice that we're using strings with the sim function when we create these symbolic variables and expressions. Once we have our symbolic variables and expressions, we can do math on them using the normal arithmetic operators. So for example, addition, subtraction, multiplication, division, exponentiation. Another thing about the sim function is that symbolic expressions are rational. In other words, they're kept in fractional form. So if you said sim 2 divided by 4, it would actually simplify it to 1/2, but it would keep it in that fractional form 1/2 rather than in the double form 0.5. There are several functions that work with symbolic variables and expressions. Simplify is going to simplify expressions, doing whatever it possibly can to simplify, including, for example, collecting like terms, and there's a function that specifically does that called collect. Expand will multiply out terms. Factor will basically do the reverse, factor a symbolic expression. Subs allows you to substitute a number into the symbolic expression. Since these expressions are kept in rational form, numden, I guess is the way you would pronounce that, is going to separate the numerator and the denominator of a fraction. So this is a function that returns 2 things. Therefore, you want to have it in an assignment statement to store the 2 values that the numden function returns. Pretty is a display function. It shows the exponents as a superscript rather than using the exponentiation operator. An easy plot will draw a nice 2D plot in the x range from -2 pi to +2 pi. Here are some examples. I've created a symbolic variable y and then multiplied that by the symbolic expression y squared. So a is now also a symbolic variable that stores y cubed. So once I have the 2 symbolic variables, a and y, I can perform any math on them. For example, a divided by y cubed divided by y is going to give us y squared. Substitute 4 into the symbolic expression stored in the variable a, which is y cubed. That substitutes 4, gives us 4 cubed, or in other words, 64. If I had the expression 1/4 plus 3/6, the default is that I would get that as a double 0.7500. However, if I pass that same expression to the sim function, it would return as a fraction 3/4. If I then pass that to the numden function, I'm going to separate the numerator of 3 and the denominator 4. And if I didn't already have a as a symbolic variable, I can make that symbolic and then expand the expression a plus 3 times a minus 2, so that multiplies that out and gives us a squared plus a minus 6. And then factor ants would give us what we started with, the a plus 3 times a minus 2. There are several functions that convert from symbolic expressions to row vectors that store the coefficients of polynomial and vice versa. Sim to poly will take a symbolic expression s and convert it to one of these row vectors that stores the coefficients of the polynomial. Poly to sim does the reverse. It converts the row vector that stores the polynomial coefficients, p, to a symbolic expression. The solve function in the symbolic math toolbox can be used to solve a single equation or a set of equations. For a single equation, it returns a symbolic expression. Once you have that, you can use the function double to convert it to an actual number. The solve function will determine for which variable to solve if you have multiple variables in your equation. If you have an x in the equation, the default is that it'll always solve for x. Otherwise, the rule is basically that it will determine which variable is closest to x if you don't have an actual x in your equation. If you have sets of equations and you pass them to the solve function, the results are going to be symbolic expressions that are stored in a structure. The names of the variables become the names of the fields. So for example, if you pass 3 equations with 3 unknowns and you call them x, y, and z to the solve function, it's going to create a structure that has 3 fields called x, y, and z in which the symbolic expressions are stored. And again, once you have the symbolic expressions, you can use double to convert those to actual numbers.